So, today our topic of discussion is area. What do we mean by this term area? What is your understanding? When you come across this term, what does that mean? So, to explicate this idea, I'm just going to use a simple graph paper. So, remember, area is when you're expressing a space in two directions. Normally, a line is if I were going from one point. So, let's start with a point. So, a point is a certain location, right? A line segment is to go from one point to another point. Now, if I change my direction, then I'll start tracing an area. Okay? So let's take the two simplest directions that we as humans we try to work with. One is the horizontal, where we sleep, right? And the vertical, where you stand. So two important directions. And that's why you'll notice that all our houses are made vertically with the floor, or our writing. In English, we write from right to left, right? In Urdu, we write opposite. In some languages, you might write vertically, right? I don't know the direction, maybe up to down or down to up. I've never learned a language that way, but these are the directions. Rarely do you see a direction like this for our writing. So this does not exist. So I'll erase that. Anyways, let's trace an area. So if I'm at this point, let's take a point. I'm down here. And I move 2 units, right? 2 spaces or 2 steps. And then I move 2 steps vertically. And then 2 steps this way. And then 2 steps this way. So what shape am I tracing? Now we've given these names to these shapes, right? Everyone watching this video will recognize this as a square. Now how many steps did I take here? 1, 2. And how many steps did I take here? 2. But inside the shape, how many squares or how many smaller squares or shapes do I have? 4, right? So if I move 2 in a certain direction, let's use a different color. 2 in a certain direction and then 2 in a different direction, right? And form the square and come back to our original point, I end up getting an area of 4 inside. This also replicates or looks like a multiplication table or a chart, right? What is 2 times 2? It's 4. Okay, let's take a different shape. Let's start maybe here. Move 4 units, 3 units, and then let's move 2 units up. And then repeat the pattern. Go here, and then come back to our original point. So I've moved 3 in this direction, and 2 in this direction. Now how many smaller squares do I see in the space? I see 6, right? So what shape is this? You'll notice it as a rectangle, right? So you've got a square, you've got a rectangle. So basically what we are doing is we are just multiplying the two sides that we have. Okay, let's look at a triangle. So if I move here, I go here, and I go here, and I go here, right? Come back. So I move two, I move two. But if you look at the shape of the square, this is what we did for the square, shape one, right? Now we are at half. We are at half the shape. So the triangle ends up becoming half of the square. So for the square, we had four complete smaller shapes. Here we have one, and we have a half, and we have a half. So what's the area traced? So the area in this case is 2. In this case, it was 4. So can I say 2 is half of 4, right? So can I say it's half of the area of a square? So these are all short forms that we could write it as. So let's define the formula then. So using the same idea, let's say if a square has length and length everywhere, same length. So the area will be L squared. If I have 2 in this spot, if I move this length as 2, then 2 will come here, so I'll get 4. If I move 3, it's going to go to 3 squared. If I go to 4, 4 squared, 5 squared, and so on. So that's our formula. Now, for a rectangle, we move a length and a breadth. It will be L times B, depending on the values of L and B. Similarly, if you have a triangle, normally for the triangle we call this the base, we call this the height h. So this is half base of height, okay? And then you have other shapes like the trapezoid. What about the trapezoid? What can you say about the trapezoid? So if you have a trapezoid, let's say if this is our length, let's mark some things. So let's say if this height is h, this height is h, and let's call this section A1. So even this would be A1. These are always parallel in a trapezoid. Let's call this section A2 and this section A3, because we don't know. In this case, they're the same, but what if they were different? Okay, so we can describe the area. Let's prove it. So the middle section, this area, is just A1 times h. And then over here for the two triangles, we have half of A2h and half of A3h. Now if you notice, you've got the half h. Let's take that common. So if I take half h common, now this part will become A2. This part will become A3, right? But this part will become 2A1. Okay, so what is a1 plus a2 plus a3? And then what is an extra a1? So let's just work on this down here. What would 2a1 plus a2 plus a3? This is just the parentheses part. So can I write this as a1 plus a1 plus a2, sorry, plus a3, right? Break this 2a1 as a1 plus a1. And then if you look at the lower line, the lower length, the upper length is a1, which is right here. And then the lower length is a combination of a1, a2, and a3. So this part is the length of the lower parallel length. So the area of a trapezoid ends up becoming this: half times h times sum of parallel sides. So this will be handy for you. Similarly, you can use circles and so on to prove. Another shape that might be interesting to you is the infamous Lego pieces that you've worked with. So let's look at a Lego piece. Let's look at this blue one, for instance. So we've got 2 this way, and we've got 4 this way. So according to my shapes, this is a rectangle. What did we learn about the area of a rectangle? You multiply these two sides, so length times breadth. So let's multiply 2 by 4, we get 8. Do we get 8 in here? So is the Lego company just working with areas? Think about it. Or multiplication. Have fun. Let's describe another thing related to shapes. It's the pyramid. So when we make a fence around our house or our yard, what are we doing? We're making a length this way and maybe this way, and it depends on the shape. So imagine if you were to walk from points A, B, C to D and back to A. So this is your direction. So let's say if this is 5 and this is 4, then you walk 5 again, then you walk 4 again. So the perimeter is just the sum of all the enclosed, of all the sides of the enclosed shape. So you just add all the sides and you get the perimeter.